The number of galaxies in the universe is not easy to estimate, as it depends on many factors, such as the size of the observable universe, the sensitivity of our instruments, and the methods of counting and classification. However, based on the latest observations and calculations, astronomers have come up with some reasonable estimates. One way to estimate the number of galaxies is to use the Hubble Space Telescope, which can observe very faint and distant galaxies. By pointing the telescope at a small patch of sky and collecting light for many hours, astronomers can create a deep image that reveals thousands of galaxies in a single frame. This is called a deep field image, and there have been several of them taken over the years, such as the Hubble Deep Field, the Hubble Ultra Deep Field, and the Hubble Extreme Deep Field. By extrapolating from these images, astronomers can estimate how many galaxies there are in the whole observable universe. According to this method, there are about 170 billion galaxies in the observable universe, which is the part of the universe that we can see with our current technology. The observable universe has a radius of about 46 billion light-years, which means it contains a volume of about 4 times 10 to the 32 cubic light-years. However, this estimate is based on the assumption that the universe is homogeneous and isotropic, meaning that it looks the same in all directions and locations. This may not be true, as there could be variations in the density and distribution of galaxies across different regions of space. Another way to estimate the number of galaxies is to use data from other telescopes and surveys that cover larger areas of the sky and detect different types of radiation. For example, the European Space Agency's Gaia mission is mapping the positions and motions of more than 1 billion stars in our own galaxy, the Milky Way. The Sloan Digital Sky Survey is measuring the distances and properties of millions of galaxies and quasars using optical and infrared light. The Planck satellite is studying the cosmic microwave background radiation, which is the oldest light in the universe and contains information about its early history and structure. By combining data from these and other sources, astronomers can refine their estimates and account for various factors that affect galaxy formation and evolution, such as dark matter, dark energy, gravity, radiation, and feedback processes. Using this method, a team of researchers led by Christopher Consolis from the University of Nottingham estimated that there are around 2 trillion galaxies in the observable universe. This is more than 10 times higher than the previous estimate based on Hubble data alone. The reason for this discrepancy is that many galaxies are too faint or too small to be detected by Hubble, but they can be inferred from other observations. However, this estimate is also uncertain and may change as new data and methods become available. For example, the James Webb Space Telescope, which is expected to launch in late 2021 too, will be able to observe even fainter and more distant galaxies than Hubble, using infrared light. This will allow astronomers to see some of the first galaxies that formed in the universe, less than 1 billion years after the Big Bang. By studying these ancient galaxies, astronomers will learn more about how they formed and evolved over time. There is no definitive answer to how many galaxies there are in the universe. It depends on how we define a galaxy, how we measure it, and how we extrapolate from our observations. The best we can do is to give an approximate range based on our current knowledge and technology. As of now, that range is between 100 billion and 2 trillion galaxies in the observable universe. However, this number may increase or decrease as we discover new galaxies or revise our methods.